Alright, my friends, welcome to this video on two problems for inductive logic. In the previous video, we looked at the notion of inductive probability and the notion of epistemic probability. Recall that inductive probability is a measure of the evidential link between an argument's premises and its conclusions. So, an argument with high inductive probability is one whose premises render its conclusion probable. An argument with low inductive probability is an argument whose premises don't render its conclusion probable, or perhaps even render its conclusion improbable. Today, in this video, we're going to talk about two problems that confront anyone who wants to develop a rigorous inductive logic. That is, a rigorous way of going about assessing the inductive probability of arguments. Right? Because we talked sort of vaguely or imprecisely about the inductive probability of arguments and how one argument might have more inductive probability than another. But we haven't made this really precise yet. We haven't given a method for how to figure out what the inductive strength of an argument is. So we'll talk a little bit about some problems with developing such a system in this video. We'll first note that deductive logic is very well studied, and we have very good, straightforward methods for testing its standards. Recall that standard being validity, right? So we have good methods for, at least in some cases, testing the validity of arguments. One example is using truth tables, which we saw in a video on Wednesday. We can use truth tables in a straightforward way to figure out whether an argument is deductively valid. Now, despite its importance, inductive logic has received considerably less attention than deductive logic in the history of philosophy, and there's much less agreement about how to assess an argument's inductive strength. So in the case of validity, we have agreement on a method like using truth tables to figure out whether an argument is valid. It's a lot less clear how we figure out exactly what an argument's inductive strength is. So if we want to go about and coming up with a more rigorous inductive logic to be comparable to systems of deductive logic that philosophers and others have developed, there's a few questions we're going to have to answer. First is, what is inductive probability exactly? We've given a definition of it, that it's the inductive probability of an argument is a measure of the extent to which the argument's premises render its conclusion probable. But we need to make that a little more precise. I mean, what exactly is it for the premises of an argument to render its conclusion probable? And the reason why we need to make that more precise, even though we have an intuitive understanding of it, is that we're going to need a more precise definition if we want to answer the question of how do we measure the inductive probability of an argument, which is what we ultimately want to do. Just like we wanted to assess whether arguments were valid or invalid, we also want a means of assessing or measuring the inductive probability of an argument. And in order to do that, we're going to need to get really clear on what inductive probability is. What is it for an argument's premises to render its conclusion probable? And these are questions that are not nearly as well studied or as well agreed upon in the history of philosophy as many of the questions regarding deductive logic. So here we'll define what a system of inductive logic is. This is what we're after. A system of inductive logic is going to consist of A, a precise definition for inductive probability, and B, a method for assessing the inductive probability of arguments given that definition. Okay? This is what a formal, rigorous system of inductive logic would be. Now, there's lots of different, coming up with an inductive logic or system of inductive logic isn't necessarily the problem in itself, because we could maybe come up with trivial ones or lots of different sorts of systems of inductive logic that wouldn't be any good. What we want is a system of inductive logic that meets a couple of criteria. That is, inductive logicians want to construct a system of inductive logic that is clear and rigorous, so everything's precisely defined, while meeting the following standards. Right? First of all, we want our inductive logic to accord well with common sense and everyday reasoning. So, in those examples we gave in the previous video, right? We want, for example, the argument in which it said that 95% of Pittsburghers are Steelers fans. Jane is a Pittsburgher, therefore Jane is a Steelers fan. We want that to come out as a better argument, according to our system of inductive logic, than an argument like more than 50% of Pittsburghers are Steelers fans. Jane is a Pittsburgher, therefore Jane is a Steelers fan. Right? Intuitively, the first argument should come out as inductively stronger than the second. Right? We want to build a system of inductive logic that accords with those intuitive judgments. Or another example, every day for my entire life so far, the sun has come up in the morning, therefore tomorrow the sun will come up in the morning as well. That's intuitively an inductively strong argument, and we want our system of inductive logic to render that conclusion. Second, we want our inductive logic to accord well with scientific practice. So scientists across the different scientific disciplines are in the business of offering arguments. And many of their arguments are intuitively, inductively strong arguments. And we want our system of inductive logic to capture their practice and to refine both common sense practice and scientific practice, but without departing radically from them. Okay, so this gives us the first problem then of inductive logic. The problem is to come up with a system of inductive logic that accords well with common sense and with scientific practice while being clear and rigorous, right? So this is the problem of constructing what we'll call a scientific inductive logic. Now, once we have a scientific inductive logic in hand, we're not totally out of the woods because there remains a deep problem that philosophers have been very interested in. And that is, how can we rationally justify the use of a particular system of inductive logic as against any other method we might employ, right? Why should a system of inductive logic accord with common sense and scientific practice, right? Why should we be seeking a scientific inductive logic? This is associated with classic problem in the history of philosophy of what's known as the problem of induction. It's often associated with the philosopher David Hume. Right? So this we might say is the problem of rationally justifying the use of scientific inductive logic. Right? And this second problem is going to be the subject of next week's video lectures. So next week we'll explore this problem of rationally justifying why we would want a scientific inductive logic to begin with. And then in much of the rest of the course, we're going to be trying to actually come up with a scientific inductive logic. Okay, so we then have two main problems for inductive logic. The first is the construction of a system of scientific inductive logic. And the second is the rational justification of the use of that system rather than some other system. Right? So the first problem is the problem of rigorously constructing a scientific inductive logic. The second is that traditional historical problem of induction. As I said, next week's video lectures are going to focus on the problem of induction. That is that second problem for inductive logic. And then much of the remainder of the course, we're going to focus on actually constructing a system of scientific logic. Okay, so you can look forward to that for next week. Please complete the participation poll for this lecture, and I'll see you next week.